Hey guys, it's Mr. Walker here, and welcome to another math lesson. This is a math lesson, right? Math lesson, okay? Of course, this is another math lesson. One of these days I'll teach you guys like some interpretive dancing or maybe some basket weaving or something like that. But today, we got another cool math lesson coming up. So what we're going to be doing in this lesson is making some connections between some of the things that we've previously learned, like area and perimeter, and finding multiples of something. So talking about like 2 times something or 4 times something, and being able to not only like multiply but reason as to what that means when we're doing 2 times something or 4 times something or 10 times something, what that means as far as place value goes and all those different things. So we're going to be taking what we know about that and also what we know about multiplication and the standard algorithm and see how those ideas kind of fit together, right? And you don't know what the standard algorithm is? No, you know what the standard algorithm is. The standard algorithm, basically, it's a fancy term for like the standard or kind of normal way that everybody multiplies, right? It's when you have a number or a problem, let's say like no 24 times 5, and you just kind of go through 5 times 4 gives me 20. Carry my 2. 2 times 5 is 10 plus 2 more would be 12. So this would be 120. If you're not super familiar with this, that's okay. We're going to definitely be going into this and exploring this a little bit more. But today we're going to be seeing kind of the behind the scenes, right? The secrets, if you will, behind why this works and how we can get to the answers when we're multiplying or finding the multiples of a number by using place value and really kind of understand why this strategy works the way it does. And what we're actually going to be using today is a strategy called partial products. Now, what that basically means is that we're just multiplying by the different place values to get our answer. So we're going to be doing some double digit by single digit multiplication. We're going to be using partial products and making those connections between what we've previously learned and kind of leading us up to actually getting really good and really familiar with the standard algorithm. So what I would like for you guys to do is make sure that you have a place value chart like I have here. If you have place value discs, that's great too. If not, you can always draw them in. I have these little like manipulatives here down at the bottom that I'm going to use to help me out. But just basically have those things ready to go. Have an open mind, be ready to work, and when you're ready to go ahead and click continue and we'll get rocking and rolling. Alright guys, so the first thing I'm going to do is I'm going to put a multiplication problem up here, and it's going to be a double digit by a single digit multiplication problem. So I want you guys to go ahead and write it down with me. And so the first one we're going to look at here is going to be 23 times 2. So go ahead and write that one down. So basically what I'm doing in this problem is I'm doing 23 2 times. I could also do 2 23 times, but it's probably going to be a little bit easier in the long run to do 23 2 times, okay? So the first thing I want you guys to do is represent the number 23 on your place value chart here using your discs or drawing in your discs or whatever it is that you need to do. So for example, what I mean by that is I would count out, let's see, 2 10s, because that would give me 20. And then I would count out 1 1, and then another one, and another one. So that would give me a total of 23. 2 10s, 3 1s is 23. So that's one copy of 23, right? I made 23 one time, but according to my problem, I want to do it 2 times. So I'm going to make a copy of that. I'm going to count out another 23. Perfect. So now I have another 23. So now I have done 23 twice, right? 23 times 2. So let's take a look now at the values that I have and kind of stack things vertically and see what we come up with. So if I look at this, I had 23 times 2. Alright, and the first thing I did, I copied my 1s, right? I did my 1s twice. So I had 3 1s to start with, and I multiplied that by 2. I did that 2 times, so that gave me a total of 6. So 2 times 3, 2 1s times 3 1s would give me 6 1s. Alright, easy enough. Then I did my 2 10s, I did that 2 times. So 2 10s 2 times would equal 4 10s, which is the same as 40. Okay, 2 1s times 2 10s would be 40. So now these are both called partial products, right? They're just a step in my multiplication. I did my 1s times my 1s, and then my 1s times my 10s. I got those two answers, a 6 and a 40. Now if I add them up, I will get 46, which is my answer. If I come over here in my chart and look, 4 tens is 40, and 6 ones, 46. Okay, so you can see how we're representing it with place value, but we're also can stack it vertically and kind of do it that way. Not too bad so far, right? Semi-easy. Let's try another example real quick. All right, so this time I'm going to take a look at 4 times 54. So we got some bigger numbers working here, but it's okay, we can handle it. So the first thing I'm going to do is I want to represent the number of 54 because I'm going to count by 54 4 times instead of counting by 4 54 times. That would take forever. So I'm going to represent the number 54 out here on my place value chart, and then we're going to basically copy that 4 times, okay? So why don't you guys go ahead and represent 54 on your place value chart, and then we'll come back and compare and see what we've got. All right, awesome. So I brought out 5 tens, as you can see right here. I have 1, 2, 3, 4, 5 tens, and I have 4 ones. So that's my number 54. Easy enough. So I'm going to make this number 4 times, basically, right? Because that's what we're multiplying by. 54 times 4. So I'm going to go ahead and make, let's see, 1, 2, that's 3 copies, and 4 copies, right? 1, 2, 3, 4 copies, and we're good to go. So now, what number do I have? What am I representing? I'm going to go ahead and write my number or my problem vertically over here. So I have that 54 times 4, right? So if we look at our ones first, we had 4 times 4, and that gave us, let's see, 1, 2, 3, 4, 6, 8, 10, 12, 14, 16. 16, okay? So I'm going to go ahead and write down 16 right here because that's how many ones I got when I multiplied 4 ones times 4 ones, or I did those 4 ones 4 times, right? And then let's go ahead and look over here at our tens. So we have 5 tens, 10 tens, which would be 100, 5 more tens, which would be 150, and 5 more tens, which would be 200. Ooh, 200. So when I did those 5 tens 4 times, 1, 2, 3, 4, I would get 200. So 4 ones times 5 tens gives me 200. So now I could add those up and I would get 216 because these are my two partial products, my ones multiplied and then my tens multiplied, and then I add them up and I get my final answer. And now if I look over here at my place value chart, if I compare the two numbers that I got, so I had 216 down here, and I had over here on the place value chart, I'm showing 20 tens and 16 ones. So, I can kind of write this as 2016, which isn't quite the same thing, but remember, we can bundle, right? We know if we have a group of 10 in any place value, we can bundle it and move it to the next place value, right? So I could take these 5 and these 5, move them over here, and they would turn into 100, okay? And then if I look, I got another 5 and 5 here, which is 10. I can move them over here, and they also would become 100. Alright, so now essentially I don't have these guys anymore, so I'll get rid of them. I just have the 200s, right? Easy enough. Let's take a look now at our ones. So the same thing, if I group them into groups of 10, I can move them over to my tens. So let's see, 2, 4, 6, 8, 10. I'll take this group right here, move them over to my tens. Perfect, so those 10 ones would turn into 110, and I can kind of just take them out of the picture. And now I'm left with just these 6 ones right here. So now I have 216, which would match what I had in my answer here. The other way we had it represented, that was still 216. It just didn't quite look the same. We bundled and moved things over to make it work, okay? So hopefully that's making some sense. Hopefully that's making some connections, because what we basically did here was find 4 times more than 54. Okay, we took that number 54 and we counted it 4 times, and that gave us our answer. And we're going to start to see how we can connect that to that standard algorithm and use some different strategies when we are multiplying by single digit and double digit numbers, and also by double digit numbers. But that's something we'll get into later. So hopefully this helps. Hopefully you enjoyed If you have any questions, comments, or concerns, please let me know. Thank you guys for watching, and we'll see you next time.